power through.
She's a little paranoid.
So now let's look at the graph for cosine.
Crawford wants us to go see her so she can give us more homework.
Are you serious?
Yes.
Oh my gosh.
I think I'm just going to ignore it.
I was gonna say, I think maybe I would just opt not to go.
Just
Just
not
say,
gonna-
oh, I'm sorry.
She said to do an announcement on campus. I'm just not going to go.
Oopsies, I was in lecture for math.
Yeah, I'm not going. I'll forget.
You just never saw the notification.
Amy, your mom can sign me out too if she wants.
I'll just sign myself up.
Okay, so
So,
cosine
I don't care.
cosine starts at 1 and goes down to -1, back up, and then back up.
So it just starts at 1.
It starts at 1, so it crosses at the half pies. So that's where its intercepts are. This valley is at pi. This is at 3/2 pi, and this is 2 pi. It's also periodic, though. It is going to repeat itself every 2 pi. It's going to do that same thing. The thing that you remember about cosine, it's a peak, valley, peak. That's how cosine works. And it starts at 1, and it valleys down to -1, and it comes back up and peaks at 1 again, unless there's been some sort of transformation. So if we want to talk about what it does, cosine of theta decreases from 0 to half pi, and it continues to decrease from half pi to pi. Then it increases from pi to 3/2 pi, and it continues to increase from 3/2 pi to 2 pi. They are both continuous. The period of both of them is 2 pi. The graph of a cosine function is even. It has even symmetry. You can fold it on the y-axis because not only does it periodically continue to the right forever, it periodically continues to the left also. So, cosine is even. You could fold it in half and it looks the same on both sides. Sine is odd. You can turn it upside down. Let me put sine in first. So this is sine. That's a sine wave in the calculator. And see, it's odd. It's got odd symmetry because if I turn it over, it looks exactly the same upside down as it does right side up. So that means it has odd symmetry. What's it saying? And then cosine has even symmetry. Because I could fold it on the y-axis. And it's the same on both sides. Okay. So now, so easy way to remember which one's which when you're looking at things.
Where it starts.
No. Cone. Sine goes down. Cosine goes up. Oh, I just did that backwards. The cone goes down. Cone. This is the cone. This is the snow. I was like, wait a minute. So the cone of a snow cone goes down, and the snow goes up. So sine goes up, cosine goes down. Hello. Okay. All right, so now let's talk about transformations a little bit. I'm going to give you a page that this is just, I mean, you can stick it in your stuff, but it's just the same stuff you already know. So that's what makes this section a little bit easier, and I think we can whiz through it pretty fast. big stack of stuff. Okay.
Can't wait for the 20 minutes waiting. I'm sure there's frost on us.
I know.
Well,
That's gonna be tough.
I didn't have to wait on it this morning because I parked under an awning.
So it wasn't.
It's not, it didn't ice at all.
My car was in the garage, but last night, I guess because, I don't know, but my husband and my son parked behind me, so this morning, and they were delayed, so I had to move this car. I didn't even keep this car in. When I got in and I was like, I can't see anything. I was just praying, please don't see anything.
So Hannah,
Yes?
has Amy White left yet?
Yes?
Okay, she hasn't come up to the office to sign out. Okay, thank you.
I didn't expect to do that.
You're supposed to do that.
I didn't do that.
Okay.
Oh well.
Yeah, I was thinking about putting my car in the car, like my little garage, but then I was like, nah, I'm too lazy. And I had to wait like 30 minutes.
I told Mother probably just to open it by the little phone.
All right, so if you'll look, you can look right in the middle and see. These are just straight, they're the same transformations you've always done. A number that is in front of a function is a vertical stretch. It's still a vertical stretch. It stretches the graph up and down. So this is the first time, because of the type of function that it is, that you'll actually see it stretch both directions, up and down. But in trig, instead of calling it a vertical stretch, we call it the amplitude.
Can you move it down a little bit? Thank you. Just another big word to use.
The A value is just a value that the sinusoid reaches both above and below the central axis. So when the function has not been transformed, the central axis is the x-axis. It reaches 1 and -1. The amplitude does. But if I write, I don't want to do it on here, but if I write this, f of x equals 2 sine theta, now instead of it going up to 1 and down to -1, it goes up to 2 and down to -2. Because the amplitude is 2 above the axis and 2 below the axis. Everybody okay? All right. The d value, that's here at the end. What does that do to a function? What has it always done to a function? Yeah, it shifts it up or down. That's it. Nothing has changed about the rules of math. It still shifts the function up and down. The d value indicates the vertical shift. It's also the central axis of the sinusoid's function at, so it'll be at y equals whatever number, or y equals d, I guess. So what that means is, let's just talk about it for a second. If I did this same function and I added a +3 at the end. So now I've shifted my central axis up 3. And then from there, my amplitude goes up 2 and down 2, which means my amplitude at the peak would no longer be at 2, but now it's at 5. But my bottom amplitude that was at -2 is now at +1 because it's shifted up and then stretched. Is everybody okay? Following? Okay. Next. I guess I can do it. Okay, amplitude. Let's talk about C because that one we know pretty well. What does C do? It's a horizontal shift. It also has a special name in trig. We call it a phase shift. Instead of just a horizontal shift, it's a phase shift. The C value indicates the phase shift. It's the place where the period begins. So on our sine wave, that was 0, 0. If we have a phase shift, it won't begin at 0, 0 anymore. It will have been shifted either right or left. That'll be at x equals c. And last, now this one, you know what it does, but we've never really dealt with it because it didn't affect anything that we were looking at. But the B value is a horizontal stretch or compression. It is used to determine the period which is the time in the x direction required to complete one cycle. It is called frequency. It is equal to the reciprocal of the frequency is equal to the reciprocal of the period. The formula that you need is period equals 2 pi divided by b. So that is the one that we haven't ever really dealt with because before we had arrowheads on everything, and because of that, you couldn't tell the difference between a vertical stretch and a compression. But now that we don't have arrowheads on everything, and now that it's a periodic function that repeats itself, you can see the difference between the two. So, hold on just a second, and let me make sure. Let me make sure I've said everything that I need to say on this paper. Okay, so you can move that if you want. Just keep it so that you can look at it if you need to refer to it. I think that we can start. Okay, so I'm going to give you this page, and we're just going to we're just going to transform them. So obviously on MyLabs, you don't ever have to draw a graph. But if you can do this, then the stuff that you have to do on MyLab should be relatively easy for you to figure out. So I think this is the best way.
So Miss Bohannon,
Yeah.
why were we taught the vertical stretch or compression if it's just called amplitude?
Why were we taught it? Because it's only amplitude if it's a
Cosine and sine?
if it is what we call a sinusoidal function.
Oh,
That's the only time
okay.
they call it amplitude. And that's because where does the word amplitude come from?
Amp.
Which is what? What is it amp?
Waves.
Sound waves, right? And the only way that they're waves is if they're sinusoidal.
Oh.
So see, parabolas and stuff, they aren't waves. So, okay. All right. So if you look at this, it'll help us. It's going to show us how to help us graph. So you can look at your original function and identify each of the pieces. So d is -1. That's the vertical shift. Now, that changes my central axis. So once I identify that I have a new D, I usually go in and instead of knowing that I'm going to have it at the x-axis, I'm going to draw in a line at -1 because that's my new axis. You can put it in dashed if you want to. I just couldn't see it if I did that. So my amplitude is 3. This time, I don't have a C value because that would be a horizontal shift, and there's not a horizontal shift in here. So it's my horizontal shift is 0. My B value is 2, which makes my period 2 pi over 2, which equals pi. Now what that means is my entire sine wave has to complete itself in pi instead of 2 pi. So is everybody with me so far? So yes.
Why doesn't it make P 2 pi over 2?
Because the formula for period is 2 pi over b, and my b value is 2, so the 2's cancel. Okay, so now that means, I'm going to use a different color so I can see what I'm doing. My sine wave usually starts at 0, 0, but because it's been shifted down, it's now going to start at negative 1, 0. And the entire thing has to be completed by pi. So I know I'm going to start and end it. I'm going to start at 0 and I'm going to end at pi. I'm also, that means halfway between, I'm going to have an x-intercept. And that means halfway between those dots, you have a peak and a valley. So that means, and it's the snow of the snow cone, so it's going to start at negative 1, 0, and it's going to go up from there. It's going to have a peak. It goes up, there's a vertical stretch of 3, so it goes up from the midline 3 spaces. So my peak is going to be 1, 2, 3. My valley will be down 3 spaces, 1, 2, 3. So it looks like this. Does that make sense? And you can repeat it over and over and over again if you want to.
Oh,
Is everybody okay? All right, so let's look at the next one. So what's your D value? 5, which means I have a new central axis. It's going to be at 5, and they didn't put an actual line there, of course. Way to go. But so just remember we're counting by 2s. My amplitude is 3 again. Your C value is pi over 4. Your period, or your B value is just 1, so your period is just 2 pi. Because it would be 2 pi over B, which is 2 pi over 1, which is just 2 pi. Which means that my period didn't get changed at all. That's all the same. But where I normally start at 0, 0, I would now be starting at 0, 5, except I have a phase shift of 1/4 pi. So that means I am now starting right here. My whole thing is going to take itself 2 pi to complete itself. So at 2 1/4 pi, it would be done. So that would be right here. At pi 1/4 is where it's going to cross. It's halfway between. You're going to have a peak and a valley. My peak is going to be 3 above my central axis and 3 below. So right there. Are y'all okay? Does that make sense? Now,
yeah.
if you were to see this, because it would have started like this. If you were to see this on a test or whatever, how do you know whether it's a sine or a cosine wave? You look at where it starts, right? And this one, in cosine, starts, it's the cone, it starts up and goes down. But couldn't this be cosine reflected? Yeah. You can't tell the difference. They'll tell you which one it is. Yes?
So quick question, just double checking. So on the first one, it was because the 2 pi was divided by 2 because of the B value, right?
Right.
And
That's
this one didn't have it, so it just be 2 pi, right?
right.
Okay.
So that too, now remember x is a liar. So normally that would, a whole number would be a stretch, but with x, it's a compression. So what it did was take my sine wave that usually takes 2 pi to complete itself, and it squashed it.
Okay.
So it completed itself in a period of pi instead, faster.
And the reason it ended just a little bit after the 2 pi is because of C, right?
It's because the C value shifted it over.
Wait, and just, so if it was like a half, it would go to 4 pi, right? If it was a half?
Yeah, yes.
Okay.
Or, like, are you talking about the shift or the period?
The period, the horizontal stretch, if it was a half. It was
Yes,
4
yes,
pi.
yes, 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 you're right. Which actually, we've got one here, but before we do this, I want you to recognize something. If you look at the way that this is drawn, and it will be drawn both ways, so you got to get used to seeing it. So notice in this notation that there's double parentheses, that the period has been pulled out, and then the shift. If it's not done that way, then you won't know what your shift is. So you have to do that. It won't affect your period because it's going to be the same. But so I'm going to factor out a half, and that would leave me x minus. If I do half pi divided by a half, it ends up just being pi. So that means my shift is actually pi, not half pi. Sometimes, and like you can see number 4, it's actually already been pulled out. All right, so my d value is up to my a value is 4. My c value is pi, my phase shift. My b value is a half, which makes my period 2 pi.
Wouldn't it be 4 pi?
I mean, 4 pi, sorry. It's 4 pi. It'd be 2 pi over a half, which you keep switch flip, and that makes it 4 pi. Okay, so I have a shift of half pi. Normally, cosine would start up at 1, 0. But now I have a shift, so it would be 1 pi, or sorry, 0, 1, and it would now be pi 1, except for I also have a shift and an amplitude change. So I'm starting here, and it would have been at 1, but now it's at 4. Oh no, amplitude is 4, so it's 6.
Why is c pi not pi over 2?
Why is C?
Oh, because
You have to
factored out.
factor the 1/2 out.
Oh, okay.
That can be confusing. So, okay. So, wait. Normally, I would
Is our starting point pi 2?
Is our wait? Is our what?
Starting point pi 2?
Well, if it was sine, it would be,
Okay.
but it's cosine, and we have an amplitude of 4. So, I mean, am I wrong here? But I mean, normally it would be here, and you multiply that by. I mean, am I wrong? There's not enough space on here. Is there? Because it should be at 8. Right? It would normally be at 3. But then from there, I'm going to go up. 1, 2, 3. It would be at 7. It would be right here. Huh. Very weird. And it's going to complete itself in 4 pi, so that means it'll be done by starting at pi. 1, 2, 3, 4 to be done at 5 pi. It'll also end on a peak. Remember, this goes peak, valley, peak.
Oh, it's cosine, okay.
Did I just do that? 1, 2. Hold on. 1, 2. I did it to go 1 too far. Here. It's right. I'm trying to figure out what line it's on. There it is. 5. Okay. So halfway between is 3. It should be a valley. 1, 2, 3, 4. Okay. I'm just going to let y'all know. I'm terrible at drawing cosine waves. I don't know why, but for some reason, starting at the top and going, I can't make it curvy. It's just going to look like a V. I try, but it just isn't going to be. It's not going to be good. So I'm just warning you. You're just terrible, but yeah, forget it. Something like that. Okay. Everybody get the basic idea? It's much easier to look at a graph of one than it is to draw one, that's for sure. Okay, so try 4. It's got a reflection, by the way. That just means it starts upside down.
So would the line still be at 2, right?
Yes.
Okay. Whoa.
Okay. Again, my curves are terrible. Just cosine. Sine waves are fine. Okay, so a couple of things. It had the reflection on it, so instead of starting up, it started down and went up. And the phase shift was plus pi, which means it goes to the left. So it started back here at negative pi.
Oh, okay, that's where I messed up.
How did you get it down like -4?
I might have gone down one too many. I think I did, actually, because it should be,
-3.
yeah, it should be -3.
I hate these lines, I don't know which one I put it on.
Yeah, it's hard to, I don't know
It's
why
hard to
it's so
know
hard to
which
tell
one.
sometimes. But it should be. No, that's,
No, yeah, that's 3.
Oh, it's not.
Yeah, it
Because
should be
the
3.
numbers are above the line they're on. Because one should be,
Yeah,
one is right
yeah,
above
see,
2, so 2's right above 2.
this is 2 and this is
Oh, okay.
3.
Yeah.
Yeah, it's just where they put the numbers that makes it look weird.
Yeah.
I just needed to move it back one.
Okay, are y'all pretty good? Are you okay, sort of, kind of?
Yeah.
Yeah.
Okay, so
Mine's are decimals.
you don't necessarily have to. Okay, but don't worry because these are decimals, but they scaled it for decimals anyway. So what they did was they actually multiplied by pi. Instead of writing it as 2 pi, they went 2 times pi, which is 6.28, and so they actually scaled it that way. So they would do the same on MyLabs if you needed to. You don't necessarily have to graph them all. If you could look at it and know what you'd be looking for. Because on MyLabs, that's going to be the most important thing. On this one, you have to factor out pi over 4. Okay, so that would be half pi divided by pi over 4, which you keep, switch, and flip. Your pi's cancel, and you get 2. So it would be x plus 2. My D value is 3.5, so it would be here somewhere. Fish. It's been shifted back to, so it would be here. And instead of starting at the axis and going up, it's got a negative on it, so it would start at the axis and go down 2.5. My period, so 2 pi over pi over 4, keep, switch, flip, so my period is 8. Finish by there. Kind of like that. Are y'all sort of okay? Anything?
Yeah. I can figure it. It just takes time still.
Yeah, it just takes a little time to figure it out. And I really don't know. I didn't. It's been since last year, and I don't know for sure. I can't remember for sure how these work. But I think that it's one where you get to click. They give you the waves, and you get to click whether you're using sine or cosine, and then you choose you type in what your phase shift is, and you.
Oh, so like the parabolas.
Yeah.
And you literally type them in equals.
Yeah, you just
And
type
then
it.
it says
You just type them in.
in
So
front of you.
it's pretty easy. But remember that the formula itself for a phase shift, the formula itself has a minus in it. So if it asks for the phase shift, like the phase shift on this one is -2 because the formula is minus. So if it says plus, it's negative. If it's negative, you just take it out. Do y'all understand what I'm saying?
Mm-hmm.
Kind of?
Meh.
Okay, so if they give you, let's see. What's your phase shift? 3.
Yeah. And then
What's your phase shift?
Oh, negative pi.
Negative pi over 2. All right, y'all should be fine on that. Okay, so one more thing. I think.
Yeah, can you help us on the graphing ones?
what do you mean
Flip the page.
Yeah.
I think we can just ignore the
Number 9.
Oh no! I mean, look. All you
how
gotta
do
do is
find the C?
look at it. What's the D value?
Oh, that's 35.
Yeah, D value is 35. So from 35, how far up does it go, and how far down does it go?
60. And 60.
25?
So that's your amplitude.
Oh, it is?
Notice though down here, look. It says cosine and sine. Why does it say that? Because you can't tell, and it doesn't really matter which one you call it. So if it's a cosine wave, What's the phase shift? Where's the peak now?
So it would be peaks down.
Well, cosine starts at a peak and goes to a valley usually. So, and my peak would normally be on the axis and shifted over a half. So shifted to the right half, so it'd be minus 0.5 or minus a half. If it's a sine wave, then it should start right here because it starts at the axis and goes up. So that would make my shift plus 1 because it's back. So that's it. And then you just got to count so to figure out your period, count from peak to peak. That's usually the easiest way. How far is it from here to here? So this is at a half, and where's this one?
6.
Is it at 6 or 6 and a half?
Fine, 6. Because you started at.
1, 2, 3, 4, 5.
Oh, okay.
So it's at
now
6 and a
I
half.
understand.
So which means it goes from a half to 6 and a half, which means my period is 6. So if period equals 6, then 6 equals 2 pi over b. Yeah? Cross multiply, and you get 6b equals 2 pi.
Wait, where did you get 6 from?
I counted from half to 6 and a half.
Oh, okay.
So that's your period from peak to peak. And then I just divide by 6 to get b. That's 2 pi. So b equals pi over 3.
You go pi.
B equals pi over 3. Even if it's a sine wave, it's easy to count. You can still count from peak to peak to count your period. It's just easy. Or valley to valley. It's just easy to do that. Okay, so let's look at, I think, this is one like that. Let's look at it real quick. This is an example from the book, so this is what I Okay, so is this a sine wave or a cosine wave?
Sine.
No, that's cosine. Because you got negative.
It is either a sine wave that's shifted pi to the right, or it's a cosine wave that's reflected. Doesn't matter. Whatever you see is whatever you call it. It doesn't
No,
matter to me.
you're wrong if you said it's cosine.
What's the
No, it's actually tangent.
what's the period? What's the period of this? When does it repeat itself?
At 2 pi?
At 4 pi.
Oh,
Because
4 pi.
it starts at 0 and it ends at 4 pi. So valley to valley.
Oh, yeah.
Which means my period, so if my period is 4 pi, then I can figure out my b value. 4 pi equals 2 pi over b. It's 4 pi. B equals 2 pi. Divide by 4 pi. Pi's cancel, so my b value is a half. What about your amplitude? From the central axis, how far up and how far down does it go? 2. So if I was writing it as a sine wave, I would write it as y equals 2 sine 1/2 x minus pi. If I was writing it as a cosine wave, I would write it as y equals negative 2 cosine. There's no shift on it. 1/2 x. Either way. Y'all okay? All right. Then they give us a function. The average temperature can be approximated by this function where x is the month and x corresponds to January, 2 is February, and so on. Observe the graph over a 2-year window, see the maximum and minimum. Y'all don't have calculators. Tell me how sure you're going to do that.
We do.
If y'all have any of those,
Use a bracket from.
if you have any of those, then you can plug it in Desmos. And I don't know, you shouldn't because y'all don't have a graphing calculator, do you? But it's in the books. So we'll see.
Books not always the option.
I notice that Weatherford gives us stuff that
I
we need that they don't allow.
So the way that it's divided up in the book, 6-3 is like vertical stretches and horizontal stretches and compressions, and then 6.4 is vertical shifts and horizontal shifts. So, I mean, I feel like this doesn't make
You could just combine.
transform everything. Yeah. So I'm gonna open them both up, and that way, if we're here tomorrow, not here tomorrow, they're open. And
Just completely do those easy.
And what I'll do is I will extend them both to the deadline of what tomorrow's was supposed to be.
Problem solved.